So the next measure of central tendency we're going to talk about today is the median. So the median is a value in which there are just as many scores greater than there are less than this value. So it's essentially just the middle value. And the first thing you want to do is actually order the values from the greatest to the smallest, or the highest to lowest, or you can do it from the lowest to highest, it doesn't matter. And then you want to find the middle position in those values. And in order to find the middle position, you're just taking the total sample size, which is n, sample size of n, plus 1, and then you're going to divide by 2, that value divided by 2. And then lastly, you'll just look at what the value of the scores are, the median score associated with that position. So what is the median value of these raw scores? 12, 12, 10, 10, 6, 5, 5. We'll talk you through it in the next slide. Again, our median position, which is different, I should be very clear here, there are two things here. There's a median position and a median value. The first thing you want to do is calculate the median position. And the median position is calculated as the sample size, or n, plus 1, and then that value divided by 2. So in this case, this is not exactly the same data as we had previously for the mean. I have 7 people here, not 6. I take the sample size, which is 7, plus 1 divided by 2, which is 8 divided by 2, and that's 4. Okay? So that is not the median value. The median value is associated with the position of the median. So median position equals 4. So if we count up 1, 2, 3, 4, the arrow here represents the median position, or 1, 2, 3, 4. Count from the top or the bottom. It shouldn't matter. If you've ordered your data correctly, it should be the same position either way. And in this case, our median position is 4, which is associated with the median value of 10. So median position is 4, 1, 2, 3, 4, or 1, 2, 3, 4, and the median value, a median score, is 10. So the median number of cups of coffee drank by the 7 people in this particular survey was 10. So the median position is sometimes referred to as the I. I is in like identity, individual, ith. You've probably heard it referred to as the ith individual. So here it's the 4th individual, or the 4th person, because we know that we're interviewing people. And everybody here is referred to as I. This is just a sort of background knowledge, just so you know, if you see it in text or in studies, that a lot of times I is referring to the individual people or the individual factors being analyzed. So if I equals 4, I'm just looking at the 4th individual, the 4th person. That's all it is. So if I equals 4, the number of cups of coffee is 10. So my 4th individual is the 4th person. I'm sorry, the 4th position for the median, and the median value is equal to the value of x at that median position. Once again, and that would be the that would be 10 cups of coffee. So if we go back and use the original data we had for the mean, the calculations of the mean, we actually only had 6 people in that data set. And this is that same data here, 12, 10, 10, 8, 5, 5, or 8, 5, 3, sorry. We have 6 people studied, and it's actually just a little bit different when we have an odd number, an even number for a sample size. So if you remember, a median position is calculated by the sample size plus 1 divided by 2. So here we have a sample size of 6 plus 1 divided by 2, which is 7 divided by 2, which is 3.5. Now you really can't have 3.5 people, obviously. So how do we calculate the median value for something that doesn't really exist in our table? It's actually very easy. All you're doing is taking the 3rd position, it's 3.5, right? So you're taking the 3rd position and the 4th position, because it's 3.5. It's somewhere between the 3rd and the 4th position. 1, 2, 3, 4. So it's between this value and this value. or 1, 2, 3, 4. So still the same. So the median position is between this 10 and the 8. So picture it like on this line, basically. And all the median score is associated with the median value of 3.5 is just the middle number between this value and this value. So the middle value between 8 and 10 is 9. If these were two much larger numbers, it would just be the middle number between those two much larger numbers. If it were 1 and 6, it would be the middle value between 1 and 6. So all you're doing is taking the middle number, or even you could even call it the average between 10 and 8. So you could take 10 plus 8 and divide that by 2, because there's 2, and that would give you 9. And sometimes it might even be the same number. If this were 10 and 10, the middle number would be 10, right? So that is the median calculated using sample size with even numbers. So the median and the mean are different. They are different, and they have in a very specific and unique way. And that is to say that medians are not at all influenced by extreme values, whereas means are. Means are probably the most widely used statistic in statistics. You use means. It is the basis for many, many, many statistical tests. With that said, though, it is influenced by extreme values. For example, here we have 6 people interviewed for how many cups of coffee they had. And then we have, one person who said 3, one person said 5, all the way up to 10. And then one person, out of nowhere, said 12 trillion cups of coffee. Clearly, that's not true. But this is an extreme example of how absurd your means can be influenced by someone's absurd answer. If someone says 12 trillion cups of coffee, your average, your mean, would actually be more than 2 trillion. Unfortunately, just because of this guy here. But if you do the median, it's still 9. The median is not influenced by this guy at all. It's still 9. So in that sense, median is much more powerful, or at least less prone to the extreme bias that this person who said he had 12 trillion cups of coffee caught, the bias he incurred. Often you see these extreme values in observational data from surveys. For example, a lot of times surveys doing interviews on high-risk sexual behavior, and there's always one out of, say, a couple hundred people interviewed who claims that they've had many, many, many dozen sexual partners in the last 12 months. And you can't disregard that number, but you do have to take it with a grain of salt. So that does influence slightly the mean. However, no one is ever going to claim that they've had 12 trillion partners in the last 12 months. And lastly, I wanted to talk about the cumulative frequency. Now, this is slightly different, slightly off topic from the median, but it is adding on to the complexities of the mean and frequency data and so on. So here we have a table that we've put together earlier, or something similar to what we put together earlier, where I've listed out this frequency data. I've got the possible number of cups of coffee. I've got 8, 7, 6, 5, 4, 3, 2, 1, 0. And I've got the number of people who had that many cups of coffee. Again, the letter F here stands for frequency. So 2 people had 8, 1 person had 7, 1 person had 6, 2 people had 5, and so on. And 3 people had 0 cups of coffee. So if you add up this frequency column, the sum of F, or sum F, sigma F, equals 17, that is your sample size. That should equal your sample size. So here, these data represent 17 different people who were interviewed about the number of cups of coffee they've had. And to find out the number of cups of coffee specifically, this is the possible number of cups of coffee. This is the categories of cups. This is the number of people who are fitting into each one of those categories. And this is the number of cups per category. It would simply be another column of Fx. We did this earlier. Fx. It's just F times X. It's the frequency times the X, or frequency times that category. 2 times 8 is 16. 1 times 7 is 7. 1 times 6 is 6. So on. You go all the way down. 3 times 0 is 0. So the sum of Fx, or the sum of this column here, would give you the total number of cups of coffee. Again, the column is called number of cups of coffee, so you would expect that the total number of cups of coffee would be represented by just a sum of that column. And in this case, it's 62. So in order to calculate the mean, you are just taking the sum of Fx, or the total number of cups of coffee, 62, dividing it by the sum of F, or the sample size, which is 17. Sum of Fx divided by n, or the sum of Fx divided by the sigma f, or sum of f, is 62 divided by 17. And that gives you 3.65. This again is just another example of the mean calculated using the frequency data that I showed you previously in the mean slide. But I introduce it now because now we're going to talk about something called the cumulative frequency. And that is here, in this slide here, in this column here. The cumulative frequency is simply the number of people starting from the bottom who cumulatively have had that many cups of coffee. So here we have 3, right? So the first row is 3 because it's 3. It's 3 people have been had 0 cups of coffee. So the first is always 3 in this case. But now one person here had 1 cup of coffee. So 3 and 1 equals 4. So now we have 4 people total. So now 3 plus 1 plus 2 is 6, right? So that's 6 cups of coffee, or 6 people up to that point. So 6 people, or up to 6 people, had 2 cups of coffee or fewer, right? I hope that makes sense. So 3 plus 1 plus 2 is 3, plus 1 is 4, plus 2 is 6. So 6 people, these 6 people here had 2 cups of coffee or fewer. And if we go even one more step, we go 3 plus 1 plus 2 plus 2 is actually 8. So now we have 8 people from this column, from this row down is 8 people. 8 people had 3 cups of coffee or fewer. 8 people. See, I represent it here. So again, the cumulative frequency is simply just adding on these numbers all the way up. And if you do it correctly, the sum of f, or the sigma of f, or the sample size, should be the same as this top row here, 17. This 17 should be the max number of people. So 3 plus 1 equals 4. Another way of doing it, instead of adding all these up and then putting the number here, so 3 plus 1 equals 4, 3 plus 1 plus 2 equals 6, 3 plus 1 plus 2 plus 2 equals 8, 3 plus 1 plus 2 plus 2 plus 3 equals 11. You could do that, or you could just do it by row. You could go 3 and then crossover plus 1 equals 4, 4 crossover plus 2 is equals 6, 6 plus crossover is 2 is 8, and so on. 15 crossover plus 2 is 17. So anyway, this is just the total number of people, and we know that the maximum number of cups of coffee drank was 8, so 17 people had a maximum number of cups of coffee of 8, and or fewer cups. And lastly, if you wanted to calculate the median position of frequency data, all you're taking is the sample size plus 1 divided by 2, and that's the median position. And in this case, the sample size is 17, right? Sum of f is 17. So 17 plus 1 is 18, and divided by 2 is 9. So for frequency data, or and you have set up the table just like this, I know my median position is 9, but I need to know the median value. So I don't count up 9 rows, unlike you do with the raw data. And then for median position for frequency data, you actually have to go up until you get to that 9th person. So here it's 3 people, here it's up to 4 people, here it's up to 6 people, here it's up to 8 people. The 9th person would have entered around this column here, around this row right here. So this is technically when it says up to 11 people, or this 11 people, it's actually up to 11 people. This is actually technically the 9th, 10th, and the 11th person are in this row, right, this box here. And this one here is technically the 12th and the 13th, and this one is only the 14th, and this one is only the 15th, and this one is technically the 16th and the 17th. So the 9th person, or the 9th position, is 3, 4, 6, 8, and in here it enters as the 9th. So that's the position, and the value, the median value, using frequency data, is simply going over here. So the number of cups of coffee is 4. I just look at the value of x when the median position is 9, and the median value is 4.